Ian Eyberg, I work at Defer Panic. We're mainly a Go shop, but if you go to deferpanic.net, we have kind of a playground of sorts where you can actually boot Unikernels right now. Anyway, so let's dive into it. But before we dive into it, I would just say that I'm going to ask a lot of pointed questions in this talk, and it might be things that you disagree with, and that's totally cool. Anyway, let's dive into it. I don't want to go over the definition of unikernels too much, mainly because there's a lot of information online. You've probably, if you're coming to this, you've probably already looked it up to some degree. But at the end of the day, what we're really talking about is the ability to cross-compile any existing application down into a very small, lightweight virtual machine that's pretty secure. So that's the basics. So it's Rails app, PHP app, Go app, whatever it is. Boil it down into a little VM. That's what we're rolling with the definition of today. Some characteristics just for the uninitiated. These are single address space systems. These are single process systems. Once again, this is for the definition of this talk. You might find other definitions online for other systems, but for this talk, this is what we're talking about. So let's jump into the history. Like, why are we even talking about unikernels? Like, why is this a thing now? It's not new. That's for true. So let's roll back the years a few bit. In fact, let's roll all the way back to the 1960s, because that's where virtualization came from. Virtualization came from IBM in the 1960s on this particular machine. So it kind of was like rolling around, lost in the wilderness for a long time. You know, it kind of dived into languages and all this, other parts of the stack. But it really came back with a vengeance in the late 90s. Diane Green, who now works at Google Cloud, and her husband, Peter Levine, and a team from Stanford came out with VMware, kind of forever changing every company in the universe. If you talk to a CIO nowadays, there's a damn good chance they pay money to this company. And what's really interesting about this was we talked about virtualization wandering in the wilderness for 30, 40 years, but then you have somebody like VMware and Citrix, and they come out with their virtualization, they productionize it, and they take it to market, all within basically a decade, which is pretty amazing when we start talking about containers. So where do containerization, where does this kind of trend come from? Once again, for the uninitiated, you might point at something like Docker, but the honest truth is, my favorite guy, Bill Joy, he was rocking chroot in 1979. So he also wrote my editor that I use every day. So he was also Sun employee and so forth. Anyways, late 1970s is kind of where the containerization trend started, in my opinion. And we have PHK, FreeBSD gels, in kind of little after the first browsers and Linux started hitting the mainstream. A few years after that, a lot of hosting companies started popping up after that, and so they immediately recognized that they had to separate these hundreds to thousands of apps that they were dealing with. So this was one of the solutions, was FreeBSD gels. Then of course we had Solaris Zones from the late great operating systems company Sun. Rest in peace. So we had that, right? Lots of good things came out of there. Unfortunately, met its demise. LXC from Google and other larger contributors, of course. And this is probably at the point where containerization actually started like hitting mainstream, and all the marketing people started being like, oh fuck, we can sell this shit. So that's something that started coming out. But my question is, like, why did virtualization win? Because for all practical purposes, virtualization was productionized and brought to market extensively within a decade, yet containerization has more or less just been kind of going on for 30 plus years. And why did it win? And The answer is quite simple. Virtualization is not containerization. I know if you go to Wikipedia today right now, they even say containers is operating system virtualization. It's like, what kind of crap is that? You know, it's total bullshit. There's so many things that are so radically different that it's literally apples and oranges. And it's completely unfair to try and compare them. So anyway, that's kind of like where we're going at. But let's put on our engineer's hat for a second. Let's start thinking and asking these pointed questions that I wanted to ask. It's pretty famous picture. You know, Ken Thompson, Dennis Ritchie, they fathered Unix, and a lot of people know them. A lot of people kind of know their history. But if you look at this computer behind you, I think that's the PDP-11. So its predecessor, the PDP-7, when it came out in the 70s, early 70s, that cost $500,000 in today's money. 500,000 K for one computer. So I think this is very important when you start talking about Linux, because multiple processes, multiple users and so forth, that might have been a technical merit, maybe, that's arguable, but it was most definitely a business decision. And we cannot forget that. It was a business decision that this computer had to have multiple users. It had to have multiple processes. And we've been stuck in that hegemony forever, for the past 40 years. Whether it had technical merit or not is irrelevant. It was a business decision. A lot of people know the guy on the left. That's, of course, Linus from Linux. Others might not know the guy on the right. That's Andrew Tannenbaum. If you've ever taken an operating systems course in your comp sci class, there's a good chance you were using his textbook. They got an infamous argument on Usenet in the early 90s, and it was basically like microkernels versus monolithics. And Linus ostensibly won that argument. Once again, maybe not for technical merit, but just for adoption and so forth. Interesting fact, that was actually forked off of Minix, which was his textbook version. So a lot of the guys who are hardcore microkernel people, they kind of went the way of the herd, which of course went nowhere. L4 and all these other systems wound up in embedded computing, academia, and all that sort of stuff. Interesting side note, this is one of these European versus American differences too. When you talk about operating systems, everybody knows like the C versus Pascal differences, but this is also another cultural difference that is prominent. Anyways, so this is point question number one. Let's look at the ops spectrum, right? So I have I've worked the entire gamut of this space. In fact, I was fighting servers right before this talk. And so if we look at the ops spectrum, and we start on the left, we talk about IT. I think that's kind of a term that should go away, but it still exists. And so let's, just because we can label, IT might be those people who install printers, or they might ship some computers around. System administrators, they're provisioning, some Red Hat, some CentOS, that sort of stuff. Both these guys, they probably don't code, maybe, but probably don't code. But if you hop over into this other quadrant, your DevOps people, they probably do code a little bit. They're the chefs, the puppets, the Ansibles, the whatever. They probably do code. And then your SREs are on kind of like the extreme right, where they are definitely engineers, but they do a lot of opsy type of stuff. And my question to you is, in this entire spectrum of IT systems, admins, DevOps, SREs, and so forth, should this even exist? Like, should that entire spectrum even exist? Should it be a thing? And I would argue, in the utopian future of ours, I would argue that it shouldn't exist. We're talking about like raw resources, water, air, and so forth. We shouldn't have to manage this. It should just exist on its own. And let's talk about configuration management. What is configuration management today? If you look at any of the tools out there, if you look at your own 1,000-line bash kludges that you have in your shops, I know you have them. It's what is it really? It's the mechanical Turk. All you did was automate the human. Like that's not really pushing the envelope there. And so it's one of these things. Another interesting trend lately has been this whole idea of serverless. It's interesting in the fact that it just points at what's been going on the past 20 years, and that is developers have been moving further and further and further away from the servers. And this is akin to unikernels in the sense that it feels like them, but they act completely differently. IoT. So a lot of people, probably in this room like to laugh at the term IoT. They're like, well, it's a bunch of fucking computers. So it's and that's true. And I think the thing with IoT is everybody gets hung up on like, well, it's toasters, it's light bulbs, it's doors, it's cars, it's they think about all the physical crap that have computers in them. What is missing here is all the computers that they're talking to. I been talking to a lot of VCs the past couple months, and I keep a list of all the batshit crazy things they say to me. This is one of them. One guy seriously was like, "Oh, I don't think server cells are actually growing anywhere." And I just had to kind of like look at him for a second, and I was like, "Are you completely insane, or just like mildly insane?" And the fact is we need 400 million new servers by 2020 easily. And I'm talking about like actual data center servers, not the bulbs and light bulbs. I mean, that's coming too, but something needs to service those. And what I'm getting at here is we're going to have to deal with this influx of managing these goddamn servers, and our existing tools and processes just won't work. This is a huge problem. People talk about security, people talk about DevOps and their liquor bottles and so forth. But that's like nothing compared to what's coming down the pipeline. We're in the kiddie pool right now. A tsunami of goddamn servers are coming our way. And really, in the future, when you have motherfuckers like this rolling around with goddamn guns and stuff, I mean, this is a sci-fi film, but this is not like so far in the future, the judge is just going to look at you and he's going to ask you, you were running Linux on that thing? I mean, seriously. Somebody rooted a Tesla a couple of weeks ago. That's crazy talk, dude. There's autonomous truck driving conventions for crying out loud. Do you want a truck driving into your house controlled by some 14-year-old who couldn't get enough GTA action? Seriously. You're fired. That's basically going to be the response to you from your boss if you're running Linux in the future. So we're engineers. We're better than this, right? Engineers, we're paid to kind of think. That's what we really do is we just think about problems. And then we spend a little bit of time like twiddling some words around to make it work. But most of all, we solve problems. So we need a new paradigm, right? We really need to be deploying software, not the systems that the software lives on. We need to be configuring software, not the systems that they're on. This is kind of a new way of thinking. It's not something that we're used to, but it's something that we have to get used to. Now for something completely different. So unikernels, this is what this talk is about, right? So if we look at the unikernel spectrum, right now the terms are all loosey-goosey, and this is a unikernel, that's a unikernel, and everybody's kind of like whatever. But let's start from the right. I've tried to divide it up into a couple groups just to kind of talk about what I would consider a unikernel. On the right, you have your domain-specific ones. So the network virtualization space is pretty hot with unikernels right now. They might not call it that, but that's exactly what it is. one of the really interesting projects came out of NEC Japan, ClickOS. They brag about booting 10,000 virtual machines on one commodity server. 10,000. They brag about live migrating them in 20 milliseconds. They brag about booting them up in 5 milliseconds. So this is, it's not just your Rails apps. It's not just your Go apps. You know, it's responding to DNS traffic. DNS request comes in, boot a virtual machine up, respond to the request in time. That actually is real. That happens today. Then you have your language-specific stuff. So the Mirage team, this is Anil. He's wandering around here, and Mir and all of them. You know, and so a lot of the Unikernel stuff you'll look at is very language-specific. Mirage is one of them. It's OCaml-based. There's HalVM for Haskell. There's Erlang on Zing for Erlang. You know, I'm sure somebody has an Ada one rolling around. And then you have the group that I am more comfortable with, and that's what I call the POSIX-speaking one. Basically, if it runs on Linux, it should work, basically. So the two kind of projects in this space are OSV and rump kernel. I'm more partial to rump kernel for various reasons, but OSV has a lot of work in it and a lot of years into it. Yeah, so a lot of these projects are not new, by the way. You might have been hearing about Unikernels, but some of them have been going along for a while. So one of the questions I get is like, well, can I run my software now, today, in a Unikernel? And honestly, the answer is yes. Within minutes, you can take an existing application and run it inside a Unikernel today. You don't have to wait till tomorrow. You don't have to wait until next year. You can do it today, within minutes. PHP, sure. Rust, I don't really use Rust, but you can. Go, obviously we use Go. Erlang, lots of Erlang stuff go on. Python, sure. JavaScript, yeah. Once again, I don't use JavaScript, but you can. Ruby, sure. You know, in terms of existing stack, you know, does Nginx work in a Unikernel? Yeah, sure. Memcache, yeah. Proxy, sure. Redis, MySQL, SQLite, sure, yeah. All that works today, right now. So this is what the talk is, right? Go Unikernels. Let's dive into that. So as many adventures begin and you know, maybe reflect, the search for a Go Unikernel took many twists and turns. If you type in Go Unikernel to Google, you might run across Clive. Clive is a project out of El Sub in Spain. Lots of people call this a Unikernel. I don't know if it necessarily reflects what I would consider as one. It's basically like Plan 9 user utilities written in Go that runs on Linux. So I mean, it's an interesting project. It just doesn't do what I wanted to do. Anyways, so I passed on this. Then I ran into this guy, Puka. This is Dr. Antti Kanti. You might have heard from Brian Cantrell that Unikernels are undebuggable. You know, and Brian's a really smart dude. So it's really easy to just kind of like take his tweets as is. But honestly, this guy, Dr. Antti Kanti, has spent the last decade, and his whole research has been, how do I debug kernel drivers without booting up an entire system? And so he had sprouted the rump kernel project from NetBSD, which of course runs on everything. And the rump kernel project was kind of designed for that. And then, you know, in the past year and a half, basically, a lot of, you know, Unikernel agitators, including myself, you know, forced the Unikernel into the rump kernel project. And so now we have this concept of a rump kernel Unikernel, which are two distinct things, by the way. So that's where I'm kind of putting my flag in is with the rump kernel guys. So running Go as a Unikernel, we're putting the pieces together, right? Kind of the first big thing that had to be done with Go was this little syscall package, right? So most languages, if say they're interpreted, they might just call out to libc and, you know, kind of be done with it. Go, with Rob Pike and everybody's infinite wisdom there, decided to hard code all the syscalls. Not only that, but in Go's own assembly. Basically, we took the NetBSD version, stubbed out a bunch of useless stuff, and then ran with it. And of course, we had to import liquor as well. So that was kind of the major hurdle. Basically, rump kernel works by hijacking any system call dynamically and then doing what it wants to in user space with it. Right now, the project is at 1.5. It's not like we don't want to go to 1.7. It's more of questioning, figuring out like what's the proper process to do this. You know, we want to be close to the we want to be close to upstream, but there's so many like major changes that figuring out how to do that in a sane fashion is an open-ended question. Before 1.4, you actually had to bootstrap any changes to the Go compiler. We still have to do that because of the changes. However, you can apt-get install it. We went ahead and added a new. Whenever I see this, I say Goose. It's Go OS. Basically, it's used as a build tag and also an environment variable to kind of figure out what architecture you're building from. So we went ahead and added a rump run one because I realized that all the changes that were made to the NetBSD version just would not fly upstream. There's just way too many different changes. So we added a new version for that. And of course, I had always used build tags in Go before, and I thought they were really cool for a while until I found them all over the goddamn Go source tree. And I was like, man, it was almost abuse of build tags in the Go source. You would not imagine the amount of crap there. And another interesting thing when I was hacking around in the Go source, what I found was so much auto-generated stuff. I guess that didn't come as a surprise. What came as a surprise was finding like Perl files that were auto-generating stuff. That must have been like one of Brad Fitz's thing. He was a big Perl dude. So that was another weird surprise. So there's these little files in there that says, do not edit. And of course, then there's a comment from me saying, oh, I edited it. Little things like that. Once again, matching upstream, that's kind of an unknown question right now. I don't know if we will ever merge. It would be great, but there's so many breaking changes, and we'll get into exactly what. So let's look at problems. So one of the big challenges of Unikernels is we're going from a multiple process, multiple address space system to a single process, single address space system. So all of our software is engineered around this old world. And so we have to slowly refactor into the new world. And there's lots of different things. For Go, this pops out immediately in virtual memory. Well, virtual memory basically works to where you can have all these multiple processes with their own little address space, and everybody's playing nice, and one address is not trying to kill another process and so forth. So this actually confuses some new Go developers because they were like, why is my process taking 140 gigs of RAM? It's not. All it did was ask the operating system, hey, can I have access to this? And the operating system's like, sure, it's fake anyways, you'll page to disk. This is a feature of of systems like Linux, whether it is or not, I don't know. So basically, once again, you have all these different processes. They want their own isolated address space. There's little boundaries in between, making sure you can't write into the other one. What's really interesting is we now know for a fact, and Microsoft and other big operating system people have done a lot of research, a lot of papers on this subject, that there's a huge performance tax for multiple address space systems. In some cases, 40%. It's huge. So when you look at these little embedded controllers with their own little, program code, and they're like, man, these are so fast, and it uses so many resources. It's really it's because it's not running goddamn Linux on it. So thread local storage. This is another kind of iffy Um, so I talk a lot of shit on the Go language design, but honestly, a lot of the design decisions are actually good. I think a lot of the Go designers kind of felt the pain in the JVM world from TLS abuse throughout the years, and so they've kind of gone out of their way to like really discourage using TLS. You know, this is one of the things where we kind of want access to it, so it's a contentious area for unikernels. Go routines, kind of on the same note. For those not used to Go, Go's answer to threading is Go routines. Basically, it handles all the heavy lifting of threading for you. It multiplexes onto real threads, and then you just kind of kick off Go routines and not have to think about it. And this is actually one of like the best things about the language for many people. But it's one of the things we have to dance around in our world. Testing sucks. So I'll just come out and say it, because when you're testing in a unikernel world, you're not just testing like your app code, which you basically have to boot up in the hypervisor and run your tests. So that's kind of a pain. But then you also have to test the actual language that you probably modified. So you know, right now testing is non-existent, and the testing frameworks are non-existent, and so it's just, you know, it's a problem area. We have to work on it. So those of you who want to work on this sort of stuff, this is something that is easily accessible. In terms of why Go is a great fit for unikernels, so this is like the flip side of the equation. Dynamic libraries have always been shunned in the Go ecosystem for many reasons. Once again, these are one of these design decisions that some people disagree with, some people agree with. In unikernel land, it doesn't really matter, because like, who the hell needs dynamic libraries? And when I'm saying dynamic libraries, I'm talking about libraries that you would load at runtime, not compile in at compile time, right? So image magic, for instance. You know, we all saw the security vulnerabilities a couple weeks ago or something. So, you know, in certain languages, you might just load that in at runtime. In other languages, you need to statically compile it. Go has always kind of shunned this. In fact, they wrote their own, so I say TLS, but in this case, TLS is the transport layer security. They wrote their own inside of Go, and to kind of obviate some of these problems. It doesn't make sense in a unikernel land, because we're dealing with single address space systems. So like, who cares about sharing across different multiple spaces? Basically, it doesn't make sense. Single statically compiled binary, this is great. All your dependencies get linked in at compile time, which makes dependencies way easier than, say, PHP or Ruby or anything like that. And of course, it's a very, very small binary. And then, of course, you know, Go has always kind of shunned the use of like fork and so forth. Basically, it's the thing of like, why can't you just code that in Go, blah, blah, blah. So it's great because we don't do fork. It's single process. So you can actually sudo apt-get install the gorump build today. And you know, it just works. In terms of like the code, it's regular Go code. So this is just a canonical example we always use. We have a fast handler, slow handler, panic handler. The fast one's fast. The slow one waits 5 seconds, and then the panic blows shit up. And so, you know, this is normal Go code, nothing special about it. This works out of the box today, right now. The dependencies are still kind of a work in progress. And I say that's a work in progress because, mainly because you're dealing with, sorry about that. You're dealing with a lot of other stuff. Looking towards the future, you know, there's a lot of interesting things happening in unikernel land right now. I think this is going to be kind of a breakout year for the ecosystem. As for the Go implementation, there's no confidence on merging right now. But you know, this is kind of a call to, other people who want to help out and work on the project. The more the merrier type of thing. Resources, rumpkernel.org is kind of like your main thing. Although I would just go to their GitHub because that's obviously where the code's at. Gorump, the packages, we've like I said, we've set up a little playground of sorts on the forpanic.net, mainly to get people rolling in the ecosystem really easily. You can just kind of spin up unikernels instantly. Literally, you can fork an example and run them in a matter of minutes. Yeah, so that's it. I think we might have 5 minutes for questions. For support for installing on OS X? Sure. Basically, I have my Mac that I'm presenting on, and I have a Linux laptop that I actually code on. So that's the answer. No, the real answer is Xhive is probably the best hypervisor for OS X that's being developed. QEMU has lots of problems, mainly because of the whole KVM needs Linux thing. So Xhive is actually native, and there is work being done on that right now. Multi-boot for Xhive is needed for rump kernels. That's kind of the current state there. I would imagine that gets done within the next month, though. So. Cool, thanks.